Welcome back everybody to day 2 of design. So I have some stuff, as you can see in the background, I've been working on. Got some concepts, not quite the 3 I said, but I got one that seems really promising, and I'm going to show you here in a little bit. And I'm going to show you them here, right here. And I'm going to get right into, let's dive right into it. Let's get going. So this is what I got for you. Behold, this space toy. What I did is I'm integrating one fan, and this fan is a fan that can be used in wet environments. Check, because it's going to have liquids in it. And that's the thing about, so we have water droplets in space. In any type of wind, air, breeze, bump, anything that hits these water drops is going to move them everywhere until they hit something else. So if I have a fan that's pulling those water drops, it's going to try and go with the flow of whatever air I'm moving. So I wanted to make a loop system. What are you doing? Say hi? She's over here doing the weather, so we won't worry about that. She's overlapping on my design work, which I don't appreciate, but it's okay. So I wanted to work in a loop system. I don't want to put any air that we circulate or that we use for suction back into the cabin where people are living and breathing. So that first cuts out a lot of filtration, that cuts out separation. So it takes a lot of the excess materials, the excess components that we need, the higher powered fans, we won't need those anymore. So what we have is we're going to have a storage tank on bottom and a fan that's going to be in between the top plate and a bottom plate, and this is all going to be enclosed. And we're going to have a lid that closes and seals off the top. Now once we open that lid, the idea is as soon as it starts to open, the fan's going to automatically turn on. And once that fan turns on, it's going to start pulling a vacuum in this tube. And this is going to prevent anything from the tank wanting to go back up where you're going to sit, which would be bad. Second of all, when I pull this air through here, I have to have somewhere for that air to vent off to. And normally they run it through a filtration system, activated charcoal, reduce all the odors. Now I'm still going to run it through like a hydrophobic filter, activated charcoal, help remove some of the odors. But I'm going to run it back in like a normal toilet we have. But instead of water coming down around the rim, we're going to use that same air. So once the air comes up, it's going to go around, and there's going to be orifices around the seat pointing down, and it's going to actually help push and create a loop and keep that air moving constantly down. And if we get any type of mist or spray that comes up with through the tank, it's going to go right back in the tank. So we eliminate all that problem, and I hope it works. All right, so I think I'm going to wrap it up for today, and I think we made pretty good progress for considering that I've only been really designing this for about roughly 2 days. So we have a design, right? We went through the process of making a decision. That's probably one of the hardest parts, is making a decision, sticking to it, designing for that, thinking about the future, because we don't want to run into any problems right at the end. So what I'm probably going to do in the next day or two is think about ways that this design can fail, what would make it not work, and see if I can improve on that. So far, it's the most promising concept I have. It's the simplest, the most compact, and it seems to, so far, meet every single requirement that NASA is asking for. So from here, I'm going to refine it. Started working on the CAD models for it. So you can see here's my base. I'm going to zoom in here for you. So that's where you sit. So I'm going to start working on these CAD models. I found the fan that I'm going to use, and it is here. Nice thing I like about McMaster-Carr is that if I go here, they give me the drawings, all the dimensions, and I can download the 3D model, and I can put right into my model. So I can save a ton of time, because now I don't have to model this fan. And it's the exact fan I'm going to use. It is, I did calculation. It was roughly about, used 40 watts of power. So we're still way under what the max is that they want to use. It moves 205 cubic feet per minute, and I think that's going to be plenty for what we're going to do. We have, I think the diameter of the waste hole is going to be roughly about 5 inches. So we're going to be moving with this fan potentially a lot of air through it. So I think that's not going to be a problem. The size fits in where I want it to. And I think everything about it is spot on to where we need it. It's going to do everything that we need to do in the restraints that we have. So a couple things, once we get the models and the basic layout, another thing we can do is we can run some analysis on it, see how it flows. The problem is that we need to figure out how to do it in microgravity. So if you ever stuck and need to make a decision, think of all your choices. Brainstorm, ask people for their inputs. I know I asked my wife, and she gave a lot of great input on things that I should think about, because not everyone can think of everything. And that's why I'm asking all of you for your input and your help. Please comment below. Let me know if you have any concerns with this design, and we can always change it. I'd rather change it now while we're in the first week than in like 3 weeks from now when we have a week left before we got to submit it for the deadline. So yeah, we're going to keep chugging along on this and see what we can come up with. I'll let you know how it goes. Till then, cheers.